Okay. Hello. You should see the desktop now. You should hear me. Let's see. I got my speaker on. Um, does everything seem okay?
Yeah.
Okay. So let me pull up the chat window. Okay. First, did everybody get their exam grade?
Yes.
I got
Okay.
exam 2,
Yeah.
not exam 1.
The exam 2, yeah. I have. I'm starting on exam 1. So the exam 2 is the one I graded first. Okay. You should have got your exam 2 grade. Uh, and remember, I mentioned in class the other day, you can look at the exam and you'll see how many points you got for each problem. Any comments? If I try to circle parts that are where there's a mistake or make a comment about what's wrong. So and an important thing is add up the points for each of your problem, because that's a real easy place for me to make a mistake is in adding up points. They don't have an automated way of accumulating the point score, so I have to add them up in my head. Okay, so add up your points and look at problems over. And if you have any questions, please send me an email. And we can talk about it over Zoom, or I can answer, or you can ask a question over email. So look the exams over, and hopefully by the end of the week I'll have exam 1 up there also. Okay, I'm right now I'm doing exam 2 of the other class, and then I go back to this class and do exam 1. Okay, so hopefully by the end of the week they'll be up. The grade will be up there. Okay, and let's see. What we're going to do. So if you have any question about the exam, please, that's not something to ask in class. So I almost never go over exams in class, because usually people have more personal questions that they want to ask about an exam about their own particular problem. So I never go over exams in class. So I really emphasize that if you have questions about the exam, please ask me in an email or come to office hours. But if you have questions, please ask about them. Okay. Now, what we want to do is continue talking about arrays. Okay. Now, let me download this one. This is where we left off on Monday. What's happening? I'm not connecting to the server. Ooh.
The same thing. I'm getting the exact same error as you for your screen.
Yeah, I
The
wonder.
only way I was able to get onto the Zoom is to go through my history.
They had a power outage on campus yesterday. I wonder if that had affected the campus. What about the campus? Is it?
Hold on, let me see if they sent out an email. I feel like they said something.
Is the campus up?
Work on campus.
I
Okay,
can't log on to my PNW. Let me check my email.
The campus is up. Okay, I mean, I have everything backed up on my computer, so I have everything available. But let me.
You want to maybe like send out, and I don't know if you're able to like send out my lunch. Send out an email to like the people that are in, because I know there's like 27 people that come to this class. There's only 18 of us right now.
Huh. There's like this.
Someone said the Wi-Fi's out on campus.
Oh. So that's keeping people. Oh, thanks for pointing that out. I didn't even know. You're right. There's only like half the classes here right now. And if they're on if the campus Wi-Fi is down, that maybe the campus network is down. So everybody here is like at home, not on campus, huh?
Yeah, and like I said, the only way I was able to get on Zoom is to literally go through my history and go to last week.
Oh.
Well, I was able to get to this Zoom via the website instead of the Brightspace. But even then, like a couple minutes ago, I was registering for a class. So I don't know, maybe it's internet be wild.
Yeah, so I logged on to my, I loaded this page just a couple minutes ago, And now it's gone. See, now it won't reload. Yeah, so it's real, it seems to be something intermediate. Oh, let's see, that time it did, let's see. No, see, it didn't load. Yeah. So it loaded when class started, I opened that page and it was there. And as in the 7 minutes that we've been in class, it's died. Okay. So this page doesn't seem to be there anymore. Okay. Not, yeah, that page isn't there anymore. Okay. So the web server has died on us just in the last couple minutes. Okay. Well, I've got those examples. I want to show you okay. I'm serving it off my desktop right now. I mean, see, you can see up here. See, I'm reading web pages off of my computer right now. So that's one of the things you can do. You can read web pages. I have them stored on my hard drive here. They should be up on the server, but right now I'm just reading them off of the hard drive. Okay, and hopefully, maybe by the time class is over with, this will get fixed. Okay, I wanted to look at these two. This where we left off yesterday was these two examples here, temperature 2, and we were doing temperature 2, and we didn't do temperature 3. Remember, the idea was that we wanted to read in a bunch of temperatures. This loop reads in a bunch of temperatures. As it's reading in the temperatures using nextint on the console on the scanner, okay, as it reads in ints from the scanner, it adds in what it reads to a running total. Then if you divide the total by the number of days, you get the average. But we wanted to know how many days were above average. So we had to ask the user again to type in their numbers to find out how many days were above average. So we want to use an array to remember what they typed in. Rather than ask them to remember and type them in, we want to use an array. So that was this one here. Okay. Now, I can take this and put it on the Java visualizer so we can watch it run. We'll look at it on the Java visualizer. And there's no trouble with the internet. You notice that I can get to the Java visualizer. It seems that campus is down. I remember they sent us an email yesterday. They had power outages problems yesterday. And I don't know if that's affected the campus today still. Okay, so here's what I'm going to do. I create an array. See, now this is, remember we talk about arrays. This is a reference to an array. This is the actual array. So this side of the equal sign creates the array of num_day numbers. So I ask the user how many temperatures they're going to give me. So I get from the user how many temperatures they're going to give me. And then I create an array to hold them. So there's creating the array, and then I create a name for that array. Now my loop it'll be just the same loop as before. I will read a number from the user, store it in the array, and also add it to my running total. So what I'm doing is I'm adding an extra line in here. I read the number from the user, store it in the array. Now notice before, every time I read a number in, I read it into the same variable. So you would read a number in, read it into the variable next, add next into the sum, loop around, get another number, and clobber the number that was there before with the new number, and then add the new number into the sum. Then loop around, read another number into that same variable. So that was why you were forgetting, because every time you read a new number, it clobbered the previous number. So there was no remembering of the numbers. They're totaled into the sum, but the individual numbers aren't remembered. So 7 plus 3 is 10, and 5 plus 5 is 10. So if I just tell you 10, you don't know if it was 7 plus 3 or 5 plus 5. So you lose all the values. Now, every time we read a number, we have a different variable to put it in, because the array has got all those slots. So we'll run it in this minute, and you'll see how now I'm creating a new variable for each entry. And then I add it into the sum, okay? And then after I've computed the average, I can go back through the array. We'll see, this for loop will step me through the array, and I can ask, is an array entry bigger than the average? And if it is, count it as above average. Okay. Now, I want to run this. Now, remember, the Java Visualizer doesn't do input-output very well. You have to give it all the input ahead of time. So I'm going to give it 5 temperature numbers, and I'll make the 5 temperature numbers say, okay, so there's my, I'll tell, there's going to be 5 temperatures, 1, 2, 2, 3, 4, 5. So I'll give it 5 temperatures. So I have to put those in this little box ahead of time. Okay, then I can go visualize. Oh, I forgot to import. I forgot to copy. I forgot to copy this import. So I forgot to copy that into the code here. Okay, now let's watch a program that uses an array. Okay, so create the scanner object. So there's the scanner that we'll be using for reading input. Now prompt the user how many days temperatures. Okay, now the number, now it's, remember the input's going to come from this box over here. So now when it reads next int, it's going to read the 5. Okay, so next int read the 5. So the 5 has been read from the input. Actually, it should disappear. I mean, it would be better if it kind of disappeared, because now the next number is 55. So the next time we read a number, we'll be reading the 55. So we've read the 5, now read the 55 next. Now, this is the interesting part. This is going to create our 5 variables for us. We need to hold 5 numbers, so we're going to create an array that holds 5 numbers, 0, 1, 2, 3, 4. Okay, so there's the 5 numbers. Remember, this thing does the ... So it doesn't show us all 5 variables yet. It shows us only 2 of them with a ... between them. Okay, so this is the name of the array, and these are the variables in the array. Okay, so now we can read in, now we're ready to read in these temperatures into that array with a for loop. Okay, so the sum is 0 because I haven't added any temperatures into it yet. Now I create the loop index I. That's going to let me loop through the index this many times. Okay, so now I prompt the user for a number. How many? What's day 1's temperature? So I prompt the user for a number. Okay, and now I'm going to read the 55. And it's going to be read into that slot there. See, now you have to read this line real carefully. I is that variable. I is 0. I is the index into the array. So that's going to go into this 0 here. So this 0 here is that number there. Okay, and I'm going to read into that. See, I read into the 0th slot 55. Okay, now I'm going to read it back. I'm going to read that slot and add it into sum. So I'm going to read the 55 and add it into sum. So sum is 55. Now I loop up. I'm in this part of the loop now. I'm checking the condition. Oh, I'm sorry. I just did the increment. So I is 1. Then I did the test. So I did so if we go back. Okay. See, we're up here. First we do the increment. There's the increment. Now we do the test. The test is true. So now we're going to print another prompt, read another input. Now I is 1. That's this slot here. That's this index here. So we're about to read, we're reading the 34 now. So we're reading the 34 into slot 1. Okay. So there's the 34 in slot 1. Okay. Now I'm going to read it back and add it to sum. So I'm going to read the 34 and add it into here and get, what is it, 89. Okay. All right. So now I'm back up here. I'm doing the increment. So I is 2. So now I'm ready to do the next slot in the array. Okay. And then that passes the test. So now I give a prompt, and now you can see what's happening. Now I is 2. That's this next slot in the array. The number 78 is going to be read into that slot. Okay. Then the number 78 is going to be read out of that slot and added into the sum. Okay. And then I loop again. Okay. Now I can just go through 2 more loops. Okay. Now I is 3. So I'm doing the slot 3. So I read the 32 into slot 3, added it into the sum. Okay. Now I'm going to increment I to 4. That's we know that's the last one. Okay. So I'm going to give a prompt. I'm going to read, see, I is 4, so I'm going to read into slot 4. Okay, and I'm reading the 22, that's the last number. So the 22 got read into there. Now the 22 is going to be added to the running total. We get 221. Okay. Now now we're back up here. So I is incremented to 5. Then we go back here to the test. Okay. I was not less than num days. Okay. Oh, actually, let me go back. See, I was 5, num days is 5, so we failed this test. 5 is not strictly less than 5. Okay, so we after doing the increment, we did the increment part. I is increased to 4. Then we do the test part, and the test part was false this time. So now we can do the average. Okay, so the average is 44.2. Okay, and then now we're going to go through the array again and look for numbers that are larger than 42. That's how many days were above average. Okay, and it looks like there's going to be 1, 2, 3 of them. Okay, so but see, we've got all the temperatures stored here now, so we can easily go. We don't have to ask the user for them again. In the earlier version, we had to ask the user for their temperatures again because we didn't have a way of remembering them. Okay, so now I start with my counter is starting back at 0. My index my index counter is starting back at 0. It's less than temp. Okay, so now I is 0. I'm reading that number and asking if it's greater than the average. Okay, 55 is greater than 42. So I'm going to add 1 into the above counter. See, so I found one of those above average. Okay, now I gets incremented. So now I'm looking at the number 34. Okay, is 34. That's see, I is 1. I'm in index 1. The value is 34. Is 34 greater than average? And the answer is no. So I'm going to skip over this and go back up to the for loop. Okay. See, I skipped over that. I didn't do the counter. So I go over here. Now I'm going to increment I to the next entry in the array. See, we call this walking down the array or traversing the array. And we do this over and over again. We tend to start at the beginning of an array and work towards the end. Now, that doesn't mean you have to do things that way. You can work from the right end of the array back up. You can start in the middle of the array and bounce back around. You don't have to traverse the array from start to finish, but that's usually the way we do it. Start at index 0, go up to the maximum index. That's how we're doing it this time. Later on, we'll see times when that's not necessarily what you want to do, but most of the time, that's what you want to do. Okay, so now we're at index 2. At index 2, there's a 78. 78 is above average, so we have to count it. Okay, now we're going to be at index 3. Index 3 is 32. Index 3 is 32. 32 is not above average, so this is false, so we don't count it. So we skip over the body of the if statement. We're back up here. Okay, now we're going to do I equals 4. That's the last entry. It's not the last time through the loop. It's the last entry. I is 4. Down here, entry 4 is 22. Okay, that's not above average. Okay, so we skip over it. Okay, now we're going to increment I to 5. Now we fail the test because now notice that the test here is written up here. The test was written using num days. And here, I wrote it a slightly different way. I wrote it as, what's the length of the array? And this is actually the more common way to do things. That way, if I wanted to change the number, if I wanted to like change the name of that variable, this would still work because this is the length of the array. Okay, so if I change the name of this variable here, where is it? I'm sorry. If I change the name of that variable there, then here I have to remember to change the name of that variable there. Except that that's really the length of the array. I really should have put this here. I kind of left it this way to make it maybe easier to read at first, but I really should have had this here because that's exactly what that is. It's the length of the array. The way it is now, if I decide that that's not a good variable name, I have to go change that variable name here, even though what's here isn't really changing. It's the length of the array. So that's why Java lets you ask for the length of an array, because every array knows its length. So this is better. So if I change the name of this variable, I have to change it here, but I don't have to change this. This stays the same. Okay, so now, right now, the length of the array is 5. 1, 2, 3, 4, 5. The index is 5. And the index is not less than the length of the array. Okay? There is no, remember, if the array has length 5, there's no fifth entry because we start counting as 0. 0, 1, 2, 3, 4. So an array has length 5, there is no fifth entry. All right, so now we drop out of this loop. Okay, and now we can just print our answers. The average is 44.2, and there was 2 days above average. The first day and the first day and the third day were above average. Okay, so this is a simple, typical use of an array to remember a large number of values that have the same kind of thing. Like in this case, we're remembering a lot of temperatures. Now, let me give you an example of what you can't do with an array. Suppose you were going to ask a bunch of people their name and their age, and you wanted to remember those. Okay, suppose that you knew there were 10 people. So you have to ask 10 people their name and 10 people their age. So you're going to get 20 results. You can't do that with an array. You can't have an array of 20 results like that. Does anybody think of a reason why? So each person gives you their name. Now, what would be the data type for a name?
String.
String. Now they give you their age. What would be the data type for an age?
Int.
Int. Okay, now you want an array to hold your 20 answers. What's the problem?
They're not the same data type.
And what's the problem with arrays?
They all have to be, all the values have to be the same data type.
Yeah, because when you declare it, see how you declare an array as array of int or array of string. See, you have to have one type there. Now, suppose you were going to do this problem of asking a bunch of people their name and their age, and you wanted to remember them. What could you do?
Make 2 arrays.
2 arrays. Yeah, you'd have to make 2 arrays. One array of strings and one array of ints. Okay, so whenever you need to remember a lot of values of the same type, you use an array. If you need to remember a lot of values of different types, you probably have to create multiple arrays. So if you're going to ask a bunch of people their name and their age, you'd have to create one array to remember their names and one array to remember their names, their ages. Okay. Later on, we'll see a way to combine the name and age into something like, a person. What if you could create something called a person that held both a name and an age? Then you could have an array of persons. And eventually that's what we want to learn how to do, was we'll be able to create an array of person where every person is really two things, a name, which is a string, and an int, which is the age. Right now, we don't know how to do that. So if we were going to do something like that, we would create 2 arrays, one of string and one of int. Okay. All right. Now, in the reading assignment, there was a section here called traversing an array. And that's what we just did. We just looked at this idea of writing a for loop. We did it. We actually traversed the array 2 times. We traversed it one time here to fill it in, and we traversed it another time here to read what was in it to count how many days were above average. Okay, this is the better way to traverse an array from beginning, from beginning to end. This was kind of a bad way to do it from beginning to end. What I did is, because this was the last end, this was the length of the array, but I gave it a name, which is really not a good idea. If you want to go up to the end of the array, always say the name of the array dot length. You know, that's the length of the array is better than having a name for the array. Now I needed this variable here. I really only needed it right there. So the only place I really needed that variable is I have to ask the user for how many days are going to be, and then create an array of that size. So I should have, in my code, done that. Okay, that would make my code better. Then notice that I'm not using num days again. I'm asking for the num days. I'm creating the array of that size, but from now on, I should use the array dot length if I want to know how long the array is. Oh, I did use the variable one other place here to compute the average. If I wanted to, I could have even done that, because I know that the length of the array is how many numbers there are. So when I create the average, I could have said this. That way, this variable, if I want to change it, it only appears here. Okay. Now, but this is maybe a little hard to read. You know, the people are used to thinking of an average as a sum over the number of items. So you can make the case that maybe it was better to leave it like this when you compute the average. Okay, so there's not always really hard and fast rules about what's a better way to write your program. Definitely in the loop, you should use the name of the array dot length if you want to go from the beginning to the end of the array. If you want to traverse from the beginning to the end of an array, always write it. Always write it I equals 0, I strictly less than. Like, if you use a less than or equal to here, you have to do something really funny here. Why do I have to do that?
Because otherwise they'll do it an extra time.
Because, well, the number of items in the array, if the length of the array is 5, there is no item at entry 5. So you have to stop one number less than the length, because we start as counting at 0. So since we start counting at 0, we have to start one number less than the length. We have to stop one number less than the length. What if you try to do the array this way? That's how many items are in the array. Yeah, that's counting. If the array has length, that's counting the length of the array from 1 to the length of the array. Almost nobody would do it this way. What's kind of bad about doing it this way?
You'd have to change it to print I instead of I plus 1. I don't know if that's bad, but it's something you'd have to change.
Oh, okay. Here I would, okay, all right. So here I would print I. Actually, that's better, but something else has to be changed. So I'm on day 1, then day 2, then day 3, okay? But now something else has to change. Let's visualize it. You'll see. You'll probably see what goes wrong when I visualize it. Okay. Let me get up to there. All right. So there's our array. Okay. Okay. Now I'm going to go day 1. You know, I'm going to day 1, day 2, day 3, day 4, day 5. Okay. So here's forward. What day 1's temperature is. Okay. Now what's going to go wrong here? Day 1's temperature is 55.
It'll store it in 1 instead of 0.
Yes, so it's gonna end up, what's wrong with that? See? It stored it at 1 instead of 0.
Because when it gets to the 5th day, it'll try to store it in 5, and there isn't a 5.
Yeah, so now we're trying to traverse the array from 1, 2, 3, 4, 5, and there is no 5 over here. So we don't write array loops like this, even though we were writing a lot of loops like that. Day 1 to day 5, we would think, okay, I equals 1, I less or equal to 5. Now I can fix this how?
If you do temps bracket I minus 1.
Yeah, because on day I want to store it in location I minus 1. Okay, so I would go back over here now, and I have to write I minus 1 here, and I minus 1 here. Now this is getting to be, nobody would really want to write it this way. There's too many weird ways of using I. Okay? Now, in a way, it looks appealing because there's days 1 through 5. See, there's the user tells us there's going to be 5 days. This is days 1 through 5. But the indexes start counting at 0, so we've got this kind of quirkiness. This is one of the things that causes lots of bugs in array. You're forgetting that you tend to count from 1, but arrays count from 0. Okay, now earlier in the semester when we were writing for loops, it usually didn't really matter that much, so whether we counted from 1 or counted from 0. Like when we were doing rows and columns, sometimes we would say, oh, we'd start with row 0. Sometimes you might say we start with row 1. Yeah, here with arrays, you have no choice. Arrays start counting at 0. Okay, so now go down here. Okay. Now, day 1, I'm at I equals 1. Days 1's temperature, but now I have to store that in the array entry I minus 1 so that it gets stored in 0. Okay, so I have to have I minus 1 here. Okay, now very few people would, this is correct. This is completely correct, but very few people would write their code that way. What we teach people is when you're working with arrays, always write your loop from 0 strictly less than the length of the array. That's the proper way to traverse an array. If you're going to want to start from the beginning and go to the end, start with the index 0 and go up to, but not including the length of the array, because there is no entry at the length of the array. So we use this pattern of setting at 0 and using a strictly less than. We didn't use this pattern in a lot of our loops earlier. We could have, but there was no great reason to say always start counting at 0. And like if you want to count 5 things, you go I equals 0, I less than 5. If you want to count 27 things, you start with I equals 0, then I less than 27. Though normally people, if they want to count 27 things, would start I equals 1, I less than or equal to 27. But not with arrays, because with arrays, the index starts at 0. You don't really have any choice. Strings were a little bit like that. I mean, well, strings are very much like that, but we didn't do that much counting of stuff in strings, so we didn't do that many examples. But strings have to be exactly the same way. If you want to go from the beginning to the end of a string, you have to go from I equals 0 up to the string dot length. I strictly less than the string dot length. Okay, so that's what we mean by that's the main idea in this idea of traversing an array, is that the best way to do it, not the only way to do it, but the best way to do it is to do it with an index starting at 0. Here, here's this example here. Let's do this one. Okay. Here's an array of string. Okay. And also here, we haven't seen this before. This is how you create an array with things in it already. We created an array of default values. When you create an array this way, you're saying how long the array is, and you want the default value in it. So let me go over here and just say, let me create another array. An array of strings. Let me create an array of strings. And I'll get, let's see, instead of calling it names, I'll call it, okay. okay, array of strings, but I'm going to say new string 5. Okay, now this one creates an empty array. This of 5 string, an empty array of 5 strings. This creates an array of filled-in array of 5 strings. So this curly brace notation lets you create an array saying the first entry in the array is this, the second entry in the array is this, the third entry in the array is this. Now, for integer arrays, the default value, we want here default values of string. What was the default value of an int?
0.
0. When we created an array over here, when we created an array of ints, they were all zeros. The default value of string, we'll see in a minute what it is. There's 2 possibilities. It could be an empty string, or it could be this word null that we've seen a few times. That would seem to be the most likely, and the answer is null. It turns out that it's not the empty string. The default value for a string is not an empty string, it's the word null. So let's visualize this one. Okay, here I'm going to create 5 empty, well, an array of 5 strings, and the array has a default value for strings in it. And see, the default value is null, 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 null. Notice I didn't use the dot, dot, dots here, whatever. Okay, but there's the 5, okay. So now there really aren't 5 strings there. This is kind of weird. I created an array of 5 strings, but I don't have 5 strings. Null is not a string. Null just means there's nothing there. Okay. Now the next one actually gave me 5 strings. 1, 2, 3, 4, 5. Okay. So in this entry arrays, in entry 0, there's Jamal, and number 1 is Emily. Okay. So there I got that 5 strings. Okay. Now, here would be a traversal of the names array, starting at 0, strictly less than names.length, increment the index 1 time, and this is just going to traverse the array and print the names. Okay, so now we start with, we create the variable I is 0, so now we print out the first name of the array. Okay, then we increment I to 1. See, we were at I is 0, now we're at I, now we increment I to be 1. So now we're at that entry in the array. So we go down here and we'll get that entry of the array and print it. Okay. And then we go up here, we're going to increment I to 3, I to 2. So that entry in the array. The third entry in the array is index 2. Okay. And then if you step forward a couple times, okay, now we're at I equals 4. That's the last entry in the array. So we printed out the last entry in the array. Now we're going to increment I to 5. That's the length of the array, but there's no 5th element. So we better stop. So we've got to the length of the array. That's why we want a strictly less than here, because we've gotten to the length, but there is no 5th element. So this will now be false. 5 is not strictly less than 5. So we're done. Okay. Now let's go back to this array and see what's going on over here. What can we do in that array? Can we put a string into it? Okay, so let's try putting a string into that array. Okay, so I would say words 1 equal dog. Okay, so there's an entry into that array. There. Okay. Now, let's back up a little bit. And there's something I want to point out, that this picture is not right. Yeah. This is not really the right picture of these arrays. This is the Java visualizer, again, doing something that's trying to make things easy, but it's doing it by showing you something that could mislead you later on. Remember how string reference variables work. So let me just create a string up here. String S1 equal, and let me create another string S2 equal let's think. What did we say that line did? Remember, this is an object and this is a reference. Strings are objects. So can you remember, how are you supposed to read a line like this? Remember, that line does three things. Anybody remember what are the three things that a line like that does? It's the same three things that this line does. The same three things that this line does. What are the three things?
It creates a string object
Yeah, and we're in the picture that's over where?
on the right.
On the heap, what we call the object. Okay, so it creates the object. Then what?
It creates a variable.
Yeah, in the stack, in the frame on the left, that's 2. Then what's 3?
It draws the arrow to the variable refers to the object.
Yeah, make the variable refer to the object. Remember, that's real important. That these are arrows and these are objects, and the reference variables point to the objects. Now, does anybody remember what's true about the Java visualizer? What would you want to warn somebody about when you get to this in the Java visualizer? What's the visualizer choosing to do here? What am I doing here? What are these guys? What do they all have in common versus these guys? What do those have?
They're primitive.
They're
variables.
primitive variables. So that means what? That's a primitive variable. So what's true about it?
It's like not referring. It just like that's what it is.
Yeah, the value is in that box. The variable holds the value. The variable holds the value. That's a reference variable. What does the variable hold?
Well, nothing.
No. It holds something.
Well, it holds the arrow.
The arrow. It holds the arrow. It holds the reference, the arrow, the thing that points to the value. So go over here to the visualizer. This is real. I'll keep doing this over and over again because it's actually unbelievably crucial for programmers to understand these ideas. Otherwise, you'll write code that's really buggy because you won't understand where references and values are, and that leads to very hard to find bugs when you goof up these ideas. So, like, look, where is 33? It's essentially in X, and 23.4 is in Y, and true is in B. Now, look, what did the Java visualizer choose to do here?
Isn't it just holding the variable?
Yeah, but yeah, that's a primitive variable. It holds its value. That's a primitive variable and it holds its value. That's a primitive variable and it holds that value. That's what?
An object.
No.
Not
That's the object. This
Yeah.
is what?
reference variable.
That's a reference variable. What is it supposed to hold?
A pointer.
Pointers.
Well,
But
bro-
what is the visualizer choosing to do?
Hold the object,
Yes, as if it were a,
primitive.
yes, it's treating strings like they look, it's making strings look like primitive variables, which is not correct. It's making strings look like primitive variables. Okay, all right. And if I keep going down here, see, okay, see, now, how do I fix that? The visualizer is choosing to draw strings as if they were primitive variables, but that's not correct. And I don't like it because I know that in the long run, if you keep thinking that way, you can make mistakes. But the visualizer lets you fix this. So remember how? Options. Show strings as objects. See, not as values. Okay, so you click there. Primitive, 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 reference variable. See, that's what it should be. Reference variable pointing at object. Reference variable pointing at object. Now, here, reference variable pointing at, now what's the object?
An array.
The array, okay? Now, here, what's interesting is this is a reference variable. An array of, since strings are reference variables, an array of string is an array of reference variables. This is an array of reference variables. Look where the string should be. Okay, I'm going to do this 2 times. Okay. I'm going to open up 2 visualizer windows, one set one way, one set the other way, but with the same code in them. I want to run the same code in the Java visualizer one way with this option and one way without that option. Okay, so with that option, same code. Okay, now without that option. There, see the difference? This is the right picture. String variables are always pointers, references to string objects. So an array of strings is an array of references to strings. This one's all kind of goofy. It's not really accurate. The string is in the reference variable. The string is in the reference variable. The string is in the reference variable, and that's not quite right. Okay. Now let me show you why I think that's a bad idea. So let me modify this a little bit. Oh, let's see. Yeah. Okay. And let me do the same thing in the other one. So notice I'm putting the word dog in the array 2 places. Okay. Now let's visualize them 2 different ways. Okay. This is the right one. So there's the primitives. Oh, I do need to expand it. Notice how there's really only one dog, and these guys both point to the same dog. Okay. Now go over here and show it the wrong way. What can go wrong here? Why does it kind of matter? Does anybody see what might go wrong? What could cause me problem here? This one's the right picture of the same code, and this is the wrong picture of the same code.
On the wrong one, one might think it's two different string objects.
Yeah, and you don't realize if you make a change in this one, you're doing what?
Making a change to the other one.
Yeah, because they're really the same object. See, there's only one string. That string appears in the array 2 times because it's pointed to from 2 different places. Okay, so there's really only one string, dog. Here it's showing it as if there was 2 strings, dog, and that can be dangerous. You might misinterpret this and think that there are 2 string objects when there really is only one string object. So this is more accurate. So this picture is supposed to make it easier for students to understand what's going on, but I think it's real dangerous to make it easier when what you're doing is also, it's easier because it's wrong. So you're obscuring a fact of Java that could lead you to make mistakes later on. So I think it's a real questionable thing for them to have done, to simplify Java to supposedly make it easier to people to learn it, but that could lead students to have a wrong idea in their head. Okay, so the visualizer wants to show strings. Now it doesn't do this with any other object. It only does it, for certain technical reasons, it only does this with strings. It wants to draw strings as if they were primitives. Okay, it doesn't do that with other kinds of objects. It won't do it with arrays, for example, but it does it with strings. But even with strings, it's still a bit misleading for it to do it that way, to treat strings as if they were primitives. Okay, all right. Now, what's important is when you have an array of objects, it's actually an array of references to objects. An array of primitives is an array of those primitives, just like a primitive variable actually holds its value. So if I go back over here, if I add a little bit to this, let me create an integer array in this one too, or a double array. A double array D's equal new, and I'll put some numbers. I won't use the new. I'll go ahead and create the array. So 1.2, 3.4, 5.6, 7.8. Okay, so there's an array of doubles. Okay. This should create an array of 4 items, and these numbers are actually in the array. Those numbers are in the array. These aren't actually in that array because they're objects. So when we visualize this one, go a couple more steps. Okay. Now notice how complicated the names array is. The names array points to an array of references that point to each of the names. If I go over here and I do the same thing with the visualizer set up the other way, okay, now if I visualize this, the picture won't look as messy, but it's a little bit wrong. There's, okay. Okay, remember, exact same code. Okay, exact same code. Hello and bye are shown like they were primitive variables. Oops, sorry. Hello and bye really should be over here in the objects. Here they're shown as if they were primitive variables. Okay, when I create the array of words, the word dog is in the array 2 times, but there's really only one word dog. Okay, whereas here it looks like there's 2 dogs. Okay. Now the array of doubles holds its values because doubles are primitives. And that's so it shows the same way. But now here, this is the trickiest one. Here, the array of strings makes it look like it's a primitive. So just like entry 0 holds 1.2, now entry 0 holds Jamal. Here, entry 1 holds 3.1. Here, entry 1 holds Emily. But in fact, over here, what entry 1 holds is an arrow to the string Emily. Array 0 holds an arrow to Jamal. Okay, so it's a little bit more complicated. Okay, so the primitive arrays are like primitive variables. The variable holds the value. The array holds the value. So the 0th entry holds that number. The first entry holds that number. Entry number 2 holds that number. But in the array, entry number 2 holds an arrow, not the string like they kind of make it look like over here. Okay. So that's something to be aware of, that we actually think of there, just like we have two kinds of variables, primitive variables and reference variables, we have two kinds of arrays of primitive variables and arrays of reference variables. So this is an array of primitives. This is an array of reference variables. And this is an array of all those words, I keep using them because eventually that's how you have to start speaking the language of programming. If to learn programming is to learn the language that people use when they talk about programs. It's just like medicine. Doctors use technical terms when they're talking to each other because they have to say very precisely what bone, what organ, what disease, so they use technical words. Well, programmers do the same. We have a technical language that we speak with, and we need to be careful we should use the technical language. Words like primitive variable, reference variable, array of primitive, array of references. Okay, so there's two kinds of arrays, just like there's two kinds of variables. Okay, so these examples are just meant to show you and you have to make notes, keep track of this, because these are the ideas that'll keep coming up. When you're starting to write your own code using arrays, you have to start, you'll have to keep reminding yourself, oh, an array of references is a little bit different than an array of primitives. And that'll affect how you do things with them. Okay, now let's look at more examples of traversing array. I got some examples pre-written that I want to look at. Okay, so here's a folder, and I'll make this available up on the website after class. Okay, I'll open these in Dr. Java. We can run them both in Dr. Java and in the Java Visualizer. Okay, what I'm going to do is I'm going to create an array of 500 numbers, and I'm going to fill it with random values. Okay, then I want to know how many times does a specific number appear in that array. And this is kind of actually like a little probability experiment. Here's what we're going to do. We're going to create an array of 500 integers. Then we're going to create 500 random integers, where each random integer is chosen between 1 and 100. So this is the way you create a random number between 1 and 100. Okay, and each number is equally likely. So you have a 1% chance of choosing each one of those numbers. Okay, now you pick one number, 100, and you ask, what we're going to do is we're going to traverse the array. So first we're going to traverse the array and fill it with randomly chosen numbers. Then we're going to traverse the array and ask, how many times was the number 100 in the array? And the answer should be around 5. Okay, because if you randomly choose 100 numbers where each number has a 1% chance, if you choose 100 numbers where each number has a 1% chance, you should on average get one of each number. But you don't get one of each number, you get almost that. So what's interesting here is that we'll get something close to 5, but we probably won't get exactly 5. Sometimes we'll get 5, sometimes we'll get a little bit more, sometimes a little bit above. Okay, so this is real important in people when you know, in games. In gaming, lots of things are done randomly. You know, you roll dice and things like that. You shuffle decks of cards. Here's how a Java program simulates things like shuffling a deck of cards or rolling a die. Here we're generating 500 random numbers between 1 and 100. So let's go ahead. Actually, let's do this in the visualizer. I don't know if the visualizer will let us do this. Let's try. We may not be able to do that many numbers, okay? Because it'd be nice to look at the array. Well, actually, let's okay, just compile it and run it first. You'll see what kind of answer you get. So, okay, I found 100 4 times. Run it again. Found 100 8 times. Run it again. Found 100 4 times. Now, 4 is closer to what you expect. In a sense, the right answer is 5 times because there's 500 numbers, and each number has a probability of 1 out of 100 of being the number you want. Okay, so you essentially it's like choosing. It's like flipping a coin 5 times, where what you're going to get is 1 out of 100. Okay, so but notice that I can get real wide variations in this. Oh, there was exactly the right thing, 5 times. You could even get 0. It's not very likely. Oh, 14 times. So like if somebody was betting on 100, they would be real lucky there. 100 showed up 14 times, way more than it should have shown up. Okay. If you do this enough, you will probably get a 0, but you might have to do this like 100 times before you get that 100 appears 0 times. There's 3 times. Okay. Now let's put it in the Java visualizer and kind of see if we can if it'll show us the array. Okay, so we're going to create an empty array of, well, it's not really an empty array. We're going to create an array of 500 zeros here. I don't know if it'll let us do this. It might tell us that's, we may have to shrink the size of the array. Yeah, it didn't. Well, let's see how far it got. Okay, you see, it didn't let us do that many loops. Let's see what it did. Okay, okay, there's my array with 500 zeros in it. Now what I'm going to do is I'm going to start looping, and I'm going to generate a random number between 1 and 100 and put it in entry I. So this is, I'm going to traverse this array and fill it with random numbers. Okay, so I'm going to go from I equals 0 to the length of the array. I called the array random ints. So that's the name of the array. That's its length. I'm going to go from 0 to the end, and I'm going to try to fill it with random numbers. So 76 is the first random number. 62 is the next random number. 67 is the next random number. Then 9, then 6, then 87. So as I'm looping, see, I'm generating random numbers. Okay, now I got to the end of my, they let me generate only a certain number of random numbers. Let's see. I don't know how many. It only let me do 12. Wow. I don't know why yeah, it only let me generate 12. It only let us generate 12 random numbers, which seems odd. That's a real, oh, probably because this array is too big, so that maybe took up too much space in their computer. So let's just try let's just try 100. Okay, if I have 100 numbers randomly chosen between 1 and 100, how many times do you think I'd find 100?
1.
Yeah, you expect it to be in there 1 time. Now it could be in there. You might actually get 0 times now, and you might get 2 or 3. Now let's see if the visualizer will let us actually, if this is within its range of what it'll let us do. No, it wouldn't even do an array of 100, but we can still see how far we got. Well, let me just go to the end. Adjust my window better. I got up to 43. I got up to 42 numbers. So it's not letting us generate two. That's one disadvantage of the Java visualizer. It doesn't let us do very large programs. So it only let us go up to 42 numbers. Okay. So the Java visualizer is not letting us do very much here. Okay, so we can go back. Let's go back to Dr. Java. Now remember, Dr. Java does let us do something kind of like the Java visualizer. So let's try this one again. Let's go here and put it in debug mode. Okay, and start the. And I have to set a breakpoint. So I'll set a breakpoint at line 13. That's the line where it's about to create the array. Okay, then I go ahead and start my program. Okay, now I'm there. Okay, now I want to see my array. So I have to tell it that I want to see the array random ints. See, that was a nice thing about the Java visualizer. You don't have to tell it what variables you want to see. Okay, so now it doesn't have a value yet. So step over. Okay, now there's my array, but notice the Java visualizer doesn't really show it very well. There's my array of, I don't know if it'll let me somehow scroll that. Doesn't seem to. See, I can open, I can kind of go like this and see more and more of it, but I can't. I don't think I'm gonna be able to see all 500 of them. I don't know if there's a trick. But the Java visualizer wouldn't let us run large things like array of size 500. Dr. Java doesn't do a good job of showing you something that's large. Okay, now I can step through this. So now let me start stepping through the loop and we'll see this thing fill up with numbers, but we can't see very much of it. Okay, so I'm going to do I'm going to start stepping through the loop. Oh, let me see my loop variable I. Okay, now why is it not found? Why is I not found? It's right there.
Is it because I only exist in the for loop?
Yeah, and where am I right now? I'm at line 17. I just got there, but what am I about? I'm about to do this, just like in the visualizer. See, I'm at line 17, and so I need to do a step into or a step over. See, now that created I equals 0. See, I needed to step into the for loop to create the I equals 0. Because when I got to line 17, I hadn't done that part of it yet. Remember, for loops, you do the initialization, then the test, then the body, then the increment. Okay, so when I got to line 17 in Dr. Java, it hadn't done the initialization yet. Now it's done the initialization. So I've got I equals 0. Now I'm about to do line 18. Line 18 is going to generate a random int and put it in the array. Okay, so I got 4. My random number was 4. Now I'm up here. I'm about to do what? I'm at line 17, and what am I about to do when I click step?
Test?
Before you do the test, what do you have to do? Remember the order. Initialize, test, the body of the loop, then what?
Increment.
Increment. Okay, notice that I haven't done the increment yet. I'm still at I equals 0. I filled in slot 0. I'm still at I0. I'm actually sitting right here in my code. So when I do another step, see, I is 1 now. So I did, now that step did the increment and the test at once. It did the increment and test. Now I'm back at line 18. Notice I've got I equals 1. So I'm about to fill in slot 1. So now I do another step, and the random number I got was 87. Okay, now I'm back up here. Now I know I'm really right there. So now when I do a step, I'm going to get I equals 2. See, I is 1 still. Okay, there's I equal 2. I got the random number 2 when I was 2. Now I is 3. And I get the random number 26 when I was 3. Okay. Now, I don't want to, if to fill up this whole array, I would have to do an awful lot of clicking. So let me show you a trick that I can do here. I can put a breakpoint down here. So I click on there and I say toggle breakpoint there. Now, if I tell it to resume, the program will just start running until it hits another breakpoint. So that will let it finish this loop and stop here where I set another breakpoint. Now, the visualizer doesn't work this way. The visualizer just, you step through all the steps. But here what I'm telling the Dr. Java is to go ahead and just run through this loop, because I don't want to step through it anymore, and just do that real fast. And then when you get to line 21, stop again. That's what the bright red line means, stop again. Okay, so now I want to see the n. So I'll go here and tell it that I want to see n when it gets there. Now, n is not found because I haven't gotten to 21 yet. Okay, now I click on resume. Okay, now I was over here. It did that loop. Notice that the array has been filled in. Okay, if I stretch this out, I can't really stretch it out too much. But the array has been all filled in. I wish I could see, I don't know if there's a way to see the whole array. Okay, but the array has been filled in. And now I'm here at line 21. Now I want to start stepping through the array and looking for 100. Now if I do a step over, see, now I have the variable n is 100. Now I'm going to go through, now I'm going to create the variable, and I want to see the variable. If I want to see the variable count, I have to type it in here myself. Okay, so now I put the variable count in my list of variables that I want. Okay. And then if I do another step, now count is initialized to 0. Now I'm going to loop through here again. Oh, notice that I is not found. That I was originally this I. Okay, but we're in between the for loops, so I doesn't exist anymore. And when I enter this for loop, this I will become that I. Dr. Java will reuse the I. Now, what it did was, it was this I when I was in this for loop, and it'll be this I when I'm in this for loop. But right now I'm in between the for loops, so I is not found. Okay, so I shows up here as not found. Okay, and then if I start stepping over, now I'm going to walk this list and I'm going to compare each of these numbers to 40 to 100. Okay, is entry I equal to n? Well, is 4 equal to 100? The answer is no. So I'm going to skip over the line 27. See, I didn't do line 27. Okay, now I'm just going to do a bunch of steps. Okay, do I have I mean, who knows where there's a 100 in here? See, now I'm at entry 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But see, I don't see where, I can't see this array. Now, here's a trick. Think, how can I find out where there's a 100. Can anybody see a trick? I want to see where there's a 100. I can't see it in here. We're almost out of time. Can anybody think of a trick that I can do? The trick is with breakpoints. A little breakpoint trick here will let me find out where there's 100 in my array. What does my program do when it finds a 100?
It increments the count.
Right, so it has to do that line, but it only does that line when it finds a 100, right? So go here and put a breakpoint there. Now do what? What can I do with the debugger? I've got a breakpoint to there. Right now I'm doing step overs, but what could I do instead? What happens if I click this button? Resume says run the program. Just start it back up again. What will happen?
Would it just keep going until the breakpoint?
Yes, but when it hits the breakpoint, what does that mean?
It means there's a 100 there.
I found 100 there. So that's how I can find out where my 100s are. By hitting resume, it'll loop until it finds a 100. Then it'll hit that breakpoint, and then I can see what I is, and I can see where there's 100. So watch. Click on resume. Oh, where's 100?
95.
100 entry 195 is a 100. I can't now look. I can't look in the array and see that. How do I find out if there's another 100?
You go back into the loop.
How? What do I do here? I've hit this breakpoint. So that means the index I tells me that that's where there's a 100. At I equal 195, there's a 100. Okay, I know it. So I know there's 100 at I equals 195. How do I find out where the next 100 is?
Would the breakpoint still be there?
Yes, the breakpoints, see, the breakpoints stay there. See how they stayed here and here? So the breakpoint's still there. So what can I do?
Just hit resume again?
Hit resume again. So that'll start the loop up. It'll loop, 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 and it'll only hit the breakpoint when it found another 100. So hit resume, 231. So that's my second 100. I found one at 231. Resume. Oh, how many 100s were there?
2.
2. And we know where there was 191 and 231. There were only 2 100s. Okay. This is how you can use a debugger to play with programs. It's a lot less visual than the visualizer. You know, it's a little bit trickier than the visualizer, but at the same time it can do much more powerful things. So notice I could play with a program with 500 integers, and I could use this to play around with it. The one thing I wish it would let you do is see the whole array. There's no real reason why it's just a flaw in Dr. Java that when we were looking at that big array, we couldn't see. We could only see a little window of the array. I mean, we should have been able to see the whole array. They should have let us double click on it, and it would like maybe pop up in a separate window. If you use a fancier debugger like IntelliJ or Eclipse, you could see the whole array in a separate window. You know, it would need a separate window to show you the whole array. Okay, well, we've run out of time. So now this was another example of traversing an array. See, that was the traversal of the array. We traversed it once to fill it in. We traversed it once to fill it in, and we traversed it another time to see how many times a number's in it. A lot like we did with the average and above average in the dot visualizer. That was a very similar pattern. We filled in an array with temperatures, computed the average, then went back through the array asking how many times we were above average. Here we went through the array asking how many times the number n was in the array. Okay, so we'll do more of these examples, well, next week. We'll keep doing examples of different ways of using arrays. Arrays are workhorses in Java programming. Arrays are ubiquitous. They're one of loops, arrays, and methods are the things, and if statements are the workhorses of programming. If statements, for loops, methods, and arrays. You know, that's what this course is really about. If statements, for loops, methods, and arrays. They're the workhorses of basic programming. So we'll do more examples of those next week. I got some more examples here, and we'll play around with traversing arrays. And then, like I said, I should have your exam 1s graded by the end of the week. So everybody check to see if you have exam 2. No new people came into class. I wonder if somebody said it appears the website works now, but no new people showed up. Yeah, you should see exam 2 graded. If you have questions about it, ask me. And you should see exam 1 graded, I hope, by the end of the week or the weekend. Okay. And if you have any questions at all, send me an email, and I'll go ahead and stop sharing here. Have a nice weekend. Bye.